Hello everyone, here is Afra Siab. Today we are going to solve Cambridge IGCSE Physics Paper 2, Multiple Choice Extended, held on May-June 2020 and paper code is 0625 with variant 23. So let's start from question number 1. Question number 1. Diagram 1 shows a solid rectangular sided block. Here is diagram 1 which shows a block. Diagram 2 shows the same block from the front and from the side. So here is diagram 2 which shows the block from the front and the side. Meter rules have been used close to the edge of the block. What is the volume of the block? So here we have to find out the volume of the block. So volume will be equal to the product of the side length of this block. So from here we can see this side is at 5 centimeter and here is 1 centimeter. So it will be 5 minus 1 which is equal to 4 centimeter. Now we consider the other side, this one. Here 11 minus 4 which is equal to 7 centimeter and the last side is 15 and 21. So 21 minus 15 is equal to 6 centimeter. So volume of the block it will be equal to product of the length of all of these sides. So I write here 4 multiplied by 7 multiplied by 6. It will be equal to 168. Unit will be centimeter cube. So from here option B is correct, which is equal to 168 centimeter cube. Question number 2. A student investigates the motion of a ball rolling down a slope. The diagram shows the speed v of the ball at different times t. So here is a ball that is rolling down a slope and its speed at different time are also shown. First of all, time is equal to 0 second. Again, speed is 0 centimeter per second and with the passage of the time speed increases. It means that speed simply changes for each time interval. Which statement describes the motion of the ball? So here we have to describe the motion of the ball. Option A, the acceleration is not constant. B, the acceleration is negative. C, speed is decreasing. And D, the velocity is constant. So here we can see that speed is not decreasing. At 0 second, speed is 0 centimeter per second. At 0.2 second, speed is 2.8 centimeter per second. At t is equal to 0.4 second, speed is 5.1 centimeter per second. It means that the speed increasing, it does not decreasing, and it also does not remain same. So it is not constant. From here option C and D is incorrect. Now we check the acceleration. So acceleration is basically A is equal to delta V over delta T. Now we check acceleration for each of these values of time and speed. So here will be A. Now I consider T is equal to 0.2 second and 0 second. So it will be 14 centimeter per second square. Now for the further time when t is equal to 0.4 second and t is equal to 0.2 second. So acceleration will be equal to 11.5 centimeter per second square. For the last interval from t is equal to 0.4 to 0.6 second, acceleration will be equal to now we can see from here that the value of acceleration for each time interval is different. First of all, acceleration is 14 centimeter per second square. Next, acceleration is 11.5 and at the end acceleration is 9.5. It means that acceleration is not constant and it is also positive. It does not have negative value. So from here option A is correct, which shows that acceleration is not constant. Question number 3. Which statement about acceleration is correct? A. It is related to the changing speed of the object. B. It is the distance an object travels in 1 second. C. It is the force acting on an object divided by the distance it travels in 1 second. D. It is the force acting on an object when it is near to the earth. So from here option A is correct, which shows that acceleration A is equal to delta V over delta T. It is just the definition of acceleration, that acceleration is equal to change in speed divided by change in time. So from here option A is correct. Question number 4. Which statement correctly describes the effects of placing a heavy load in a car? So when we place a heavy load in the car, what will be its effect? Option A. It is easier to accelerate the car and easier to bring the car to rest. B. It is easier to accelerate the car but more difficult to bring the car to rest. C. It is more difficult to accelerate the car and more difficult to bring the car to rest. D. It is more difficult to accelerate the car but easier to bring the car to rest. So first of all, consider that there is a car at this position and there is also a heavy load that is placed in this car. So what will happen? The mass of this car increases. When the mass increases, then we require a greater force to accelerate this system. So here I require a greater force. That's why it is very difficult to accelerate as well as to bring the car to rest. So from here option C is correct. That is very difficult to accelerate the car and more difficult to bring the car to rest. Question number 5. Which row gives the correct weight for the mass shown? The value of G is 10 Newton per kilogram. So mass is given in kilogram and weight is measured in Newton. Here we have to find out that which row describes correctly the weight corresponding to given values of the mass. So first of all, we know that weight is equal to product of mass and G. The value of G is 10 Newton per kilogram. We check all of these given possibilities A, B, C and D. So for A, weight will be equal to mg. Mass is given 2 kilogram. 2 multiplied by 10, it will be equal to 20 Newton. So here weight is equal to 20 Newton, which is correct. We also check other ones. For B, weight will be equal to mass is 10 multiplied by the value of G is 10. So it will be 100 Newton, which is incorrect. Here it is given 1. For the C, weight will be equal to 10 multiplied by 10, which will be 100 again. It is given 10, that's why it is incorrect. For the last option, here is 20 and value of G is 10. So total will be 200 Newton, but here it is given 2. That's why this option is also incorrect. Only A is correct, which shows that mass is equal to 2 kg and weight is equal to 20 Newton. Question number 6. A rectangular gymnasium is 50 meter long, 25 meter wide and 8.0 meter height. The density of the air is 1.2 kg per meter cube. What is the best estimate of the mass of the air in the gymnasium? So here we have to find out the value of mass. Density is also given. So I write here density is equal to mass over volume, and mass is equal to density multiplied by volume. So density is 1.2. Volume will be equal to length multiplied by width multiplied by height. Now I am going to put values here. It will be 1.2 multiplied by length is 50 multiplied by 25 and then 8.0. So the value of mass will be equal to 12,000 kilogram. So from here option D is correct. Question number 7. Which moving object has the resultant force acting on it? Option A. A diver rising vertically through water at constant speed. So here speed is constant. It means that speed is not changing. Its value is same at each interval. So I write acceleration is equal to delta V over T. It will be U, V minus U over T. So when the speed is constant, then acceleration will be equal to 0. I just put acceleration is equal to 0, then V minus U over T is equal to 0. From here V is equal to U, which shows that speed is constant only when acceleration is 0. So when the acceleration is 0, then according to Newton's second law, F is equal to ma. When A is equal to 0, force will be equal to 0. It means that there is no resultant force acting on the diver rising vertically through the water at constant speed. So it is incorrect. Option B. An aircraft circling an airport at constant speed. So here the aircraft circling an airport, it means that it is moving into the circular path. So when a body moves into the circular path, I draw here. There is a force that is acting towards the center. This force is basically the centripetal force. So there is a resultant force acting on the aircraft circling an airport at constant speed. Here the speed remains constant, only the direction of the speed changes. So by changing the direction of the speed, there will be acceleration which is constant. So option B is correct. We also see the other. A parachutist descending vertically at the terminal velocity. So here is terminal velocity means constant speed. When there is constant speed, again acceleration is equal to 0, then force will be equal to 0. So it is also incorrect. D. A train going up a straight slope at constant speed. So this is also incorrect. Question number 8. Which quantity is not a vector? So which one of these is not a vector? Option A. Acceleration. B. Temperature. C. Velocity. D. Weight. So acceleration is the vector quantity. Temperature is not a vector quantity. So this option is correct. Also the velocity and weight is a vector quantity. Question number 9. A ball falls vertically to the floor and rebounds vertically upwards. Just before it hits the floor, its speed is 4.0 meter per second. As it rebounds, its speed is 3.0 meter per second. The mass of the ball is 0.50 kilogram. What is the change in momentum of the ball? So here we have to find out the change in momentum of the ball. First of all, momentum is the product of mass and speed. When we have to find out the change in momentum, it will be delta P, which is equal to m and delta V. Here m, final speed minus initial speed. So mass is given, which is 0.50 multiplied by the value of V is 3.0 minus U is 4.0. But first of all, the ball falls vertically to the ground. First of all, it falls and then rebounds back. So its direction changes. There will be minus 4.0. So it will be 0.50 multiplied by 3.0 plus 4.0. 0.50 multiplied by 7.0. So delta P, which is change in momentum, it will be equal to 3.5 kilogram meter per second. So from here in C and D, it is given that 3.5 kilogram meter per second. But what's the direction of the momentum? Either it is downwards or upward. So its direction will be upward in the direction of the final speed. So from here option D is correct. Question number 10. A mass bounces up and down on a steel spring. The diagram shows the mass and the spring at different points during the motion. So first of all, here is a spring. This is highest point. When this spring stretch, then the mass moving downward shown here. Then when it is full stretched, then position is lowest point, and at the end mass moves upward. At which point does the mass have the least gravitational potential energy, and at which point is the most elastic energy stored in the spring? So gravitational potential energy basically related with the height, because gravitational potential energy is equal to mgh. So where the gravitational potential energy is least and the elastic potential energy is maximum. The elastic potential energy will be maximum where there is more extension in the spring. So from here we can see that spring is maximum stretched in the lowest point here. So the most elastic energy stored in the spring will be at the lowest point. Next we check the least amount of the gravitational potential energy. If I suppose that the highest point is the mean position of this spring, then it is moving downward. This is extreme position. So the gravitational potential energy will be least at the extreme position, while the gravitational potential energy will be maximum at the mean position. So here we have to tell that where the gravitational potential energy is least. So it is the extreme position, which is the lowest point. So at the lowest point the gravitational potential energy will be less. So from here the least amount of gravitational potential energy will be at the lowest point. So option D is correct. Question number 11. The velocity v of an object increases as it falls towards the ground. Which quantity is directly proportional to v square? Option A, speed of the object. B, gravitational potential energy of the object. C, kinetic energy of the object. D, the momentum of the object. So first of all, here is a term v square, which is speed, the square of the speed. So speed will not be directly proportional to v square. It is incorrect. In the option B, gravitational potential energy is equal to mgh. So there is no term of V square. This is also incorrect. Next is kinetic energy. It is equal to half mv square. From here, kinetic energy is directly proportional to V square. So this option is correct. We also check momentum P is equal to mv. So here is only a term of V, not V square. So momentum is also incorrect. Question number 12. The diagram shows a solid block resting on a bench. The dimensions of the block are shown. Here is 40 cm, 20 cm and 80 cm. On which labeled surface should the block rest to produce the smallest pressure on the bench? Find P, Q, R. P, Q and R produce the same pressure. First of all, there are three surfaces, P, R and Q. We check the surface area for each of these surfaces. We can see here that P contains the largest area. I write here P has larger area. So pressure will be equal to force over area. Pressure is inversely proportional to area. So if the P has largest area, then its pressure will be lesser. So from here, only the surface P has smallest pressure because of its largest area. Option A is correct. Question number 13. A pipe full of water connects a water supply on a hill to the tap lower down the hill. The length of the pipe is 500 meter. The height of the supply above the tap is 100 meter. The density of water is 1000 kg per meter cube. The effect of atmospheric pressure is negligible. What is the water pressure at the tap? So here we have to find out the water pressure at the tap. I write here P is equal to rho GH. Here rho is density, G is acceleration due to gravity and H is height. So density is given 1000, multiplied by the value of G is 10 and the height, as we have to find out the water pressure at the tap, so the height above the tap is given, which is 100 meter. So I write here 100. So the value of pressure will be equal to the unit of pressure is Pascal. So from here option C is correct. Question number 14. When the molecules rebound from a wall, a force is exerted on the wall. What caused this force? Option A. The kinetic energy gained by the molecule. B. The kinetic energy lost by the molecule. C. The change of momentum of the molecule. D. The change of speed of the molecule. So first of all, if I consider that here is a box and there are molecules. These molecules collide with each other and also with the wall of container. So when these collide with this wall, then they bounce back in the opposite direction. So there will be change of momentum, due to which they exert a force on the wall. So there will be change of momentum of the molecule. Option C is correct. Question number 15. The relationship between the pressure P and the volume V of a gas is given as PV is equal to constant. Under which condition for the mass of the gas and for its temperature does the equation hold? So here mass is given and also the temperature. Option A, changing, B, changing constant, C, constant changing, D, constant. So here PV is equal to constant. It means that V is inversely proportional to P. That volume is inversely proportional to pressure. This is according to Boyle's law. And here, temperature and also the mass, both of these should be constant. These are fixed. So option D is correct. This is just the statement of the Boyle's law. Question number 16. The diagram shows a liquid in glass thermometer. Which row gives the correct label for the thermometer? X and Y. X shows water, alcohol, water, alcohol. And Y shows the narrow tube of uniform diameter and this and immersed in substance to be measured. So first of all, alcohol is used in the liquid in glass thermometer because it expands maximum when we increase the temperature. Also, the narrow tube of uniform diameter makes the liquid in glass thermometer more sensitive, due to which option B is correct, which shows that X is alcohol, Y narrow tube of uniform diameter. Question number 17. The diagram shows 4 blocks of steel. The blocks are all drawn to the same scale. The same quantity of the thermal energy is given to each block. Which block shows the greatest rise in temperature? So first of all, here are 4 blocks A, B, C and D. We see that the volume of the block A is small as compared to block B, C, D and E. So the amount of heat energy transferred to this block easily. So it has greater rise in temperature. So option A is correct because you can supply heat to the block A easier due to its smaller volume. That's why it shows the greatest rise in temperature. Question number 18. Why are metals better conductors of thermal energy than the non-metals? Option A. They contain free electrons. B. Their molecules are further apart. C. Their molecules vibrate at a high frequency. D. They have smoother surfaces. So here, metal contains free electron while non-metal does not have free electron. So option A is correct. Question number 19. The diagram shows a vacuum flask used to keep a liquid warm. So here is a vacuum flask. Which methods of heat loss are reduced by the vacuum between the silvered walls? Conduction only. B. Conduction and convection only. C. Convection and radiation only. D. Conduction, convection and radiation. So first of all, here we place a vacuum between the silvered wall. Here we place this to reduce the heat loss due to conduction and convection. So from here option B is correct, which shows conduction and convection only. Question number 20. An earthquake monitoring station records the arrival of 16 complete waves of earthquake waves in 20 seconds. The speed of the earthquake wave is 6.0 km per second. What is the wavelength of the earthquake wave? So here we have to find out the wavelength. I write here wave equation V is equal to F lambda and lambda is equal to V over F. Speed is given 6.0 km per second, but we don't know the frequency. So first of all, we find out the frequency. It is given that 16 complete waves in 20 seconds. I write here it is 20 seconds. For one complete wave, it will be 20 divided by 16, which is equal to 1.25 seconds. So this is time. F is equal to 1 over t. Frequency and time are reciprocal to each other. So it will be 1 over 1.25, which is equal to 0.8. Unit is hertz. Now I put values here. V is 6.0 into 10 की power 3. 10 की power 3 is because of the kilo, and frequency is 0.8. So wavelength will be equal to 7500 meters. It will be 7.5 into 10 की power 3 meter. So from here option D is correct. Question number 21. The diagram shows a wave. What are the amplitude and the wavelength of this wave? So here we have to find out the amplitude and wavelength. Amplitudes are given in centimeter and wavelength is also given in centimeter. So first of all, we see this figure. Amplitude is the maximum distance of a body from its mean line. This dotted line is actually mean line or mean position. So the maximum distance of a vibrating body from its mean position is basically amplitude. Now I will draw the distance which is equal to amplitude. This distance is also be shown by this arrow, which is given 3 centimeter. It means that amplitude is equal to 3 centimeter. Next we find out the wavelength. Wavelength is the distance between two consecutive crust or trough. Now I am going to draw the distance which is equal to one wavelength. So if I start from this, then I also have to end at the same location like this. So this distance is basically equal to wavelength and it is given 8 centimeter here. So wavelength will be equal to 8 centimeter and the amplitude is equal to 3 centimeter. So here will be option B. Amplitude is 3 centimeter and wavelength is 8 centimeter. Question number 22. Which statement is correct? Option A. The speed of light in a glass is equal to the speed of light in a vacuum multiplied by the refractive index of the glass. So here it is given that V is equal to C multiplied by N. But we know that N is equal to C over V. Refractive index is the ratio of the speed of light in the vacuum to the speed of light in the glass. So here C will be equal to V multiplied by N. Both of these are reciprocal. That's why option A is incorrect. Option B. The incident angle of the light ray at an air glass surface is the angle between the ray and the glass surface. So angle of incidence is basically the angle that the incident ray make with the normal. So this option is also incorrect. C. The sine of the critical angle at an air glass surface is equal to 1 over refractive index of the glass. Here it is given that N is equal to 1 over sine C, where C is the critical angle, or we can write sine C is equal to 1 over N. So this option is correct. Option D. The angle of refraction for light passing through an air glass surface is proportional to the angle of incidence at that surface. So this is also incorrect. Only option C is correct from here. Question number 23. Which statement about converging lenses is correct? Option A. A real image of an object projected onto a screen by converging lens is always inverted. Option B. The image formed by a converging lens is always upright. C. The image formed by the converging lens when used as a magnifying glass is real image. D. Parallel rays entering a converging lens are focused at a distance greater than the focal length of the lens. So from here, option A is correct. Because when the real image is formed by the converging lens, then it should be inverted. It will be like that. If I consider it's a converging lens, and if the object is here, then the image formed here. Option B is that the image formed by the converging lens is always upright. So it is not correct that always the image formed by the converging lens is upright. So option B is incorrect. C. The image formed by the converging lens when used as a magnifying glass is actually virtual and upright. It is not real image. So option C is also incorrect. Parallel rays entering a converging lens are focused at a distance greater than the focal length of the lens. So this option is also incorrect. Question number 24. An intruder alarm sensor detects that a person is warmer than his surroundings. Which type of electromagnetic wave does the sensor detect? Infrared, radio, ultraviolet, visible lights. So these are basically infrared. Question number 25. Two people are standing outdoors on either side of the high wall. So here is a high wall and two persons are standing on the opposite side of this wall. Person 1 can hear person 2 talking although he cannot see her. Which statement explains this? Option A. Sound wave have diffracted around the wall. B. Sound wave have passed unaffected through the wall. D. The sound waves has diffracted around the wall. So, the person 1 can hear the person 2. It is because of the reason that there is diffraction of the sound. So, option A is correct. Question number 26. Four nails A, B, C and D are tested to find which makes the strongest permanent magnet. One of the nail is placed against a bar magnet and the number of paper clips which the nail can support is recorded. So first of all, here is a bar magnet that contains north and south pole. There is also the nail that is attached with the bar magnet and paper clips. The bar magnet is then removed and the number of paper clips remaining attached to the nail is recorded. Each nail is tested individually. Which nail becomes the strongest permanent magnet? Number of paper clips attached to the nail when bar magnet present and when the bar magnet is removed. So there are given two. Number of paper clips attached when the bar magnet is present and 0 when the bar magnet is removed. It means that in this question, when more number of paper clips attached with the nail, stronger will be the nail, and here nail is basically used to make the strongest permanent magnet. So in the option A, first of all, when the bar magnet present, then there are 2 number of paper clips, but when the bar magnet removed, there is 0 paper clip attached. It means that here is 0% of the nail remains. Of the nails remain. So option B is 2 and 1. It means that 50% of the nails remain. I write here. Option C, 4 and 3. Almost 75% of the nails remain. And option D, 5 and 2. Here almost 40% of the nails remain. So here 75% is largest among all of these. It means that option C is correct. When there are maximum number of paper attached with the nail, then there will be strongest permanent magnet, which is nail. Nail is used basically here for the strongest permanent magnet. So from here option C is correct. Question number 27. The diagram shows a magnetized steel rod inside a solenoid connected to a potentiometer. In diagram 1, the potentiometer is connected to a DC power supply. In the diagram 2, the potentiometer is connected to an AC power supply. So first of all, here are two diagrams 1 and 2. Here is DC power supply in diagram 1, while the AC power supply in diagram 2. Which action would demagnetize the piece of steel? Option A. In diagram 1, move the potentiometer slide from P to Q. B. In the diagram 1, move the potentiometer slide from Q to P. C. In the diagram 2, move the potentiometer slide from R to S. D. In the diagram 2, move the potentiometer slide from S to R. So first of all, potentiometer works only when there is AC current, not the DC power supply. It means that the figure 1 is excluded due to the DC power supply here. Next, we have to demagnetize the piece of the steel. It means that we have to decrease the current. But how we can decrease the current? If I move this at position R, then what will happen? Current is passing from here in this direction, then like this, and it stops at the point R. It means that current decreases as the potentiometer slides from S to R. From S to R, current decreases. As a result, the piece of steel demagnetizes. So from here, option D is correct, which shows that move the potentiometer slide from S to R. Question number 28. The diagram shows a positively charged conducting sphere and a wire connected to the earth. So here is a wire is connected with the earth, and there is also the insulating support. The positively charged sphere is placed here. What happens when the wire is touched onto the sphere? Option A. Electrons flow from earth to the sphere. B. Electrons flow from the sphere to the earth. C. Positive charges flow from earth to the sphere. D. Positive charges flow sphere to the earth. So from here, first of all, this sphere is positively charged. So through this conducting wire that is attached with the sphere and also with the earth, electrons move from the earth towards the sphere. Because sphere is positively charged, due to the attraction between the positive charges and the electrons are attracted from the earth towards the sphere, which is positively charged. It means that the electron move from earth to the sphere. So from here, option A is correct. Question number 29. A student uses a circle shown to determine the resistance of the two identical resistors. So here are two identical resistors. I suppose that first is R1 and second is R2. The voltmeter reading is 2.2 volt and the ammeter reading is 0.25 ampere. What is the resistance of each resistor? So here we have to find out the resistance of each resistor, which is R1 and R2. It is given that voltmeter reading is 2.2 volt. It means that potential difference is 2.2 volt, while the current is 0.25 ampere. First of all, I find out the equivalent resistance of this circuit, which is also equal to the total resistance. I use Ohm's law. V is equal to IR and R is equal to V over I, where V is 2.2 divided by 0.25. So R will be equal to 8.8 ohms. Next we can see that R1 and R2, both of these are in series. And in the series, I write here total resistance will be equal to the sum of individual resistances. It is also given that the two resistances are identical. If I suppose here R1 is equal to R2 is equal to R prime, then this equation becomes R is equal to R prime plus R prime. The value of R is 8.8. It will be equal to 2R prime. So R prime will be equal to 4.4 ohms. From this equation, it will be 4.4 ohm. So R1 is 4.4 ohm. R2 is also equal to 4.4 ohm. So from here, option C is correct. Question number 30. There is a current of 2.0 ampere in the resistor of resistance 8.0 ohm. How much power is dissipated in the resistor? So here we have to find out how much power is dissipated. So here I use the formula P is equal to I square R. Current is given, which is 2.0 ampere, and resistance is also given, which is 8.0. So I write here 2.0 square multiplied by 8.0. It will be equal to 32, and the unit of power is watt. So from here, option D is correct. Question number 31. The lamps, the diodes and the batteries in the circuits are identical. In which circuit does the ammeter give the greatest reading? So there will be the greatest reading on the ammeter, means that there is a large amount of the current passing through the circuit, which is only possible when there is forward biasing. So in the option A, we see a circuit. This is negative side and this is positive, again negative and positive. For the diode, this is negative while the arrow is positive. So this is positive and negative. We can see that this negative is attached with the negative and also this positive is attached with the positive. So this circuit is forward biased. There is maximum current passing through this circuit. So option A is correct here. It gives the maximum current due to which the ammeter reading will be larger. We also check the other options. So it is negative, positive, negative and positive. This negative is attached with this negative, but this positive is attached with this negative. So there is also reverse biasing and forward biasing. Current will be minimum. So option B is incorrect. For option C, here is plus minus. We see here that negative attached with the negative and this positive basically attached with the negative, due to which there is also the forward biasing and current will be lesser in this case. Option D. So here we can see positive is basically attached with the negative and this negative is basically attached with the negative. So there is also one diode which is reverse bias. Current in this case will be minimum. So the greatest current will be in the case of A. So ammeter gives the maximum reading for the option A. Question number 32. The two resistors are connected in series with the power supply. Which statement about the circuit is correct? Option A. The current from the supply is greater than the current in individual resistor. B. The current from the supply is equal to the current in each resistor. C. The current from the supply is less than the current in each resistor. D. The current from the supply is the sum of the currents in each resistor. So, we have two resistors and both of these are connected in series. It means that there is only one path for the flow of current. There is also the power supply here. I write here power supply and here is R1, R2. So when the resistances are connected in series, the current that is supplied by the power supply will be equal to the current in each resistor. In the series combination, current remains same. If I say that the current supplied by the power supply is 2 ampere, it means that I2 is equal to 2 ampere, also I1 is equal to 2 ampere. So the current remains same. From here option B is correct, which shows that the current from the supply is equal to the current in each resistor. Question number 33. Which two logic gates each have high output when both of their inputs are high? So here, when both of the inputs are high, 1, 1, the output is also high. So this is true for the two logic gates. We have to identify these logic gates. First of all, in the option A, here is AND and OR, B, AND and NOR, C, NAND and NOR, D, NAND and OR. So, for the case of OR gate and AND gate, in the OR gate, we say that if any one of the input is high, the output is high. So when I consider inputs 1 and 1, then both of these inputs are high, the output will be high, which is equal to 1. In the NAND gate, we say that if both of the inputs are high, the output will be high. So here both of these inputs are high, the output will be high. So in the case of AND and OR gate, when both of the inputs are high, the output will be high. So option A is correct. Next question number 34. The diagram shows a series of logic gates and a part of its corresponding truth table. What are the missing values in row 2 of the truth table? So here we have to complete the truth table. Here we can see that two inputs P and Q, and when these inputs are joined by the AND gate, it gives output R. And when P and Q are joined by the OR gate, output is S. Next, R and S act as input, and next there is NAND gate. When we apply NAND gate, then there is output T. We have to complete the truth table given below. So first of all, here is R. R is the output of AND gate. Inputs in this case is 0 and 1. So when in the AND gate, when both of the inputs are high, the output will be high. Otherwise, the output is low. Here 0 is low, due to which the output will be low. Here will be 0. So I write here 0. S is the output of OR gate. In the OR gate, if any one of the input is high, the output will be high. Here 1 is high input, that's why the output will be high. So both of these 0 and 1, when we apply NAND gate, first of all we apply AND gate, then invert the value to apply NOT gate. So 0 and 1, when we apply AND gate gives 0, and when we apply NOT gate, 0 changes into 1. So that's why here will be 1. So option B is the possible option, which shows 0, 1, 1. So we have complete the truth table according to given circuit. Question number 35. The graph shows how the current in the three circuits vary with the time. Here is circuit 1, circuit 2 and circuit 3. In the circuit 1, we can see that there is a sinusoidal wave, but its polarity is same, means that its values are positive. It varies from 0.5 to 1.5. In the circuit 2, we see here that the values varies minus 1.0 and 1.0. So in the case of circuit 2, there is a change of polarity. But in the third circuit, there is only a single value of the current, which is 1.0. In which circuits is there is our direct current. So where is the direct current? Direct current is basically the current that does not change its polarity. So circuit 3 is the direct current, because here is a straight line which shows that current flows in one direction. So this is direct current. We also check the circuit 1 and circuit 2. In the circuit 1, there is no change of polarity. So it is also the direct current, but circuit 2 is AC current, because here the change of polarity involved. There will be minus 1.0 and 1.0. So that's why circuit 1 and 3 shows the DC. Option B is correct. Question number 36. The coil of a simple AC generator rotates steadily in a uniform magnetic field. The diagram shows the position of the coil at t is equal to 0. So this is the position of the coil shown in this figure. Which graph shows the output voltage for one rotation of the coil? So the output voltage will be sinusoidal. So here in the option A, there is sinusoidal wave, which is correct. B, it is cosine wave. So the output voltage is not cosine. So this is incorrect. C, this is for the DC supply, but in the generators we use AC supply. So that's why option C is also incorrect. Same for the D. D is also incorrect because here is output voltage which is DC. So only option A is correct. Question number 37. What occurs during the nuclear fission? Question number 37. What occurs during nuclear fusion? So here is the process of nuclear fusion. Option A. Two light atomic nuclei join together and emits energy. B. Two light atomic nuclei join together and absorb energy. C. A heavy atomic nucleus splits and emits energy. D. A heavy atomic nucleus splits and absorb energy. So in the fusion, basically there is the fusion of atomic nuclei. They join. So in the option A and B, it is given that the two light nuclei join together. So this is basically the process of fusion, and either the energy emits or absorbed in this case. So in the fusion, there is the emission of large amount of energy when the two light nuclei combine. So option A is correct. In the B, it said that there is the absorption of energy, which is incorrect. In the nuclear fusion, there is the emission of energy. So option A is correct. Question number 38. A radioactive material has a half-life of 20 days. A sample of material contains 8.0 into 10 to the power 10 atoms. How many atomic nuclei have decayed after 60 days? So first of all, it is given that the half-life of the radioactive material is 20 days and the initial concentration of the sample is given, which is 8.0 into 10 to the power 10 atoms. We have to find out the number of decayed atoms after 60 days. So first of all, I find out the total number of half-lives. It will be equal to total time, which is 60 days, divided by half-life, which is 20 days. It will be equal to 3. It means that total 3 half-life passes. So when no half-life pass, T is equal to 0. The number of atoms are 8.0 into 10 to the power 10. When the first half-life pass, then half of this amount decay, and there will be 8.0 into 10 की power 10 divided by 2, which is 4.0 into 10 की power 10. These atoms remains behind. After second half-life, the half of this amount remains behind. So here will be 2.0 into 10 की power 10. After third half-life, it will be 2.0 into 10 की power 10 divided by 2, which is 1.0 into 10 की power 10. So these are basically the undecayed atom, but we have to find out the decayed atom. So decayed atom will be equal to number of atoms present originally, that is 8.0 into 10 की power 10 minus undecayed, which is 1.0 into 10 की power 10. So it will be equal to 7.0 into 10 की power 10. So from here option D is correct. Question number 39. A thin sheet of paper is placed between a radioactive source and a radiation detector. The count rate falls to very low reading. So here is a source and we have placed a paper between the source and the detector. From this result, which type of radiation is the source emitting? So which type of the radiation source emitting here? First of all, when we place a paper between the source and the detector, then the count rates fall. It means that there are the radiation that can be stopped by the paper. So these are basically the alpha particles that can be stopped by the paper. Beta particles and gamma rays pass through these. So from here, option A is correct, which shows alpha particles. Question number 40. Alpha particles, beta particles and gamma rays are emitted by the radioactive nuclei when they decay. Which emissions can be deflected by an electric field? So which one of the following emissions can be deflected by the electric field? Option A, alpha particles and beta particles only. B, beta particles and gamma particles only. C, gamma rays and alpha particles only. D, alpha particles, beta particles and gamma rays. So only those emission can be deflected by the electric field that has charge. So here alpha particles are just like helium nuclei and these are positively charged. Beta particle has negative charge, while the gamma rays are neutral. They don't have any charge. It means that the alpha particles and beta particles can be deflected by the electric field because of their charge. So from here, option A is correct, which shows alpha particles and beta particles only.